This problem, we have a function. We're going to show the setup to find the area under the curve. And remember that area under the curve really means the area between the curve and the x-axis. And that includes negative area. So if area is underneath the curve, then it's counted as negative. I'm sorry, I said that weird. I said the area beneath the curve. What I meant was if the curve is under the x-axis, then the area is negative. So we are just setting this up, and I want you to be able to use sigma notation because it does save time. You also need to recognize sigma notation. That will become super important later when we get to chapter 4. But we are going to go from -3 to 3, and we have this function. So you don't really need to draw the entire function. Like -x cubed plus 5x plus 4, I could start sketching it. It really doesn't even matter. What I do is I kind of set up a number line. And I say, okay, from -3 to 3. Okay. Now I am using 6 left endpoint rectangles. So if I split this into sixths, what is the width of each rectangle? So -3 to 3, that's a total distance of 6. And I'm splitting that into 6 rectangles. So my delta x, aka my width, is 1. So when I'm setting this up using a sigma, because it's a sum, and by the way, this is called a Riemann sum. Riemann sum is finding the area of rectangles using left endpoint rectangles, right endpoint rectangles, midpoint rectangles. We call that a Riemann sum. It's just a guy who formalized this in mathematics. Okay, so we are adding up 6 different rectangles, right? We have 6 rectangles. With left endpoint rectangles, it's always good to start with n equals 0. Okay, with left endpoint rectangles, we're going to start with n equals 0. And then we have a total of 6 rectangles. So I'm plugging in all the integers. You can never, and I'm going to write this down, you can never have index values that are decimals. So I'm not allowed to start with n equals 0.5 and end at n equals 5.5, okay? That's not a thing. It has to be integer values only, okay? And I say this because on your ESA for this stuff, so many people try to use decimals. You can't do that, okay? So we're going to start with n equals 0, like I said. And then to have a total of 6, I'd be plugging in 0, 1, 2, 3, 4, and 5. Because that's a total of 6. 1, 2, 3, 4, 5, 6. So we're going to plug in n equals 0 to 5. And then think about the area of each rectangle. It's going to be width times height. Base times height. Now my width, I already figured out, of each one is just 1. And since they're all widths of 1, I'm allowed to do this. I can just factor it out. But the heights are not all the same height, right? To find the height, I would have to actually plug stuff into the function. So I'm going to set that up as f of, and then this is where it gets a little tricky. Because if you think about your heights, it's going to be f of -3, then f of -2, then f of -1, f of 0, f of 1, f of 2. I will not be doing f of 3 because that's on the right-hand side, and I'm using left endpoint rectangles. So how do I get it so that if I plug in n equals 0 to 5, I get -3, -2, -1, 0, 1, and 2 by plugging in 0 to 5. So this is the formula you can use. It's going to be width times n. So in this case, the width is 1. So our width, or our delta x, shows up in 2 places, here and here. Width times n plus your starting value. And we're starting at -3. So this is the beginning of the interval, is that -3. So we get 1 times f of n minus 3. Now, if you don't believe me, plug in 0. You would get f of 0 minus 3, which is f of -3. If you plugged in 1, you would get f of 1 minus 3, which is -2. If you plugged in 2, you would get f of 2 minus 3, which is -1. If you plugged in 5, we should get 2, right? Let's plug in 5. 5 minus 3 is f of 2, so it works out. Okay. All right, let's do right endpoint rectangles. So similarly, our entire width is 12. I'm sorry, our entire width is 6 to go from -3 to 3. That's a width of 6. And we're dividing that into 12s. So that's going to be 1/2. Each rectangle has a width of 1/2. Now with right endpoint rectangles, we're not going to start with n equals 0. We're going to start with n equals 1. Okay, and I'll talk more about that later, why that is. So n equals 1, I have a total of 12, so I'm going to end at 12. Because if I start at 1 and end at 12, I'm plugging in the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that is a total of 12. Then I'm going to do width, which is 1/2, times my height, which is f of, and then we're going to actually use the same formula for left endpoint rectangles. 1/2 n, so my width times n minus 3, the beginning of my interval. The reason why this works is if you plug in if you plug in 1, you get 1/2 times f of 1/2 minus 3, which is -2.5. Okay, so let's think about like the number line thing again, okay? So I'm starting at -3, I'm ending at 3. I'm splitting this into 12ths, right? Okay. So when I do this, I am starting at this point here. I'm not actually going to be starting at -3. My interval begins at -3, but my starting point is going to start to the right of that. Like my first rectangle is going to start at -2. I'm sorry, -2.5. Because again, the width of each rectangle is 1/2, right? So if our interval starts at -3 and then we go over 1/2, now we're at -2.5. And that's actually where my first rectangle begins, is at -2.5. My next rectangle will go up 1/2 at -2. And then my next rectangle will be -1.5, et cetera, until I get to 3. But the idea here is we are still going to begin our interval at -3. And then when I plug in 1 into this formula, instead of plugging in 0, if I plug in 1, I begin to the right of the beginning of my interval instead of starting on the interval. If I plug in n equals 0, I'd be starting at -3. But I don't want to start at -3. I want to start to the right of -3. So that's why we're going to start with n equals 1 instead of n equals 0. But otherwise, the formula works out to be the same pretty much as left endpoint rectangles. The only change is which n value you start with. And then 3 trapezoids. The question is, do you need to use sigma notation for trapezoids? What's the expectation here? We're going to use the trapezoidal rule. That's all I want you to be able to do, is use the trapezoidal rule. So no sigmas for trapezoids. Just use the trapezoidal rule. Keep it simple. So the trapezoidal rule works like this. A trapezoid is your width times the average of your heights. We can factor out a delta x, we can factor out a 2, and then we're just adding the heights. So we're going to have delta x over 2, and then we're going to add up our heights. So if we have 3 trapezoids, we have a total width of 6. We're dividing that into 3 trapezoids. The width of each trapezoid is 2. Okay, so delta x is 2. We're going to be dividing by 2 because that's just like part of the formula, is like that average part. And then thinking about our 3 trapezoids, our first trapezoid starts at -3. Okay. Our next height is going to be 2 units later, because our delta x is 2. 2 units later would be f of -1. Now, if you think about the way trapezoids work, right? When they're sitting all next to each other, the ending heights only apply to one trapezoid. Okay, this is trapezoid number 1, this is trapezoid number 2. Sorry, number 3. And the ends are only adjacent to one trapezoid. But the middle heights are adjacent to 2 trapezoid. So like this height is used for the first and the second trapezoid. And then this one is used for the second and the third trapezoid. So what happens is your middle heights occur twice. So f of -1 and f of positive 1. Again, I'm increasing my x values by 2. And then my last height is only adjacent to one trapezoid, so I only use f of 3 once. So it's going to be your beginning and end only once, but your middle pieces are going to be twice. So that's how I would set up this with the 3 trapezoids. Just use the trapezoidal rule. Don't get super fancy. Just do delta x divided by 2. Middle heights occur twice because they're shared. Ending heights occur only once.